Okay, we're going to go ahead and go over the review for the multiplying our mixed numbers test. Our number one has a area model of 3/5 times 1 and 1/4. What we're going to do for the answer is we're going to combine these two area models. We have 3/5. We're going to take our two answers and our two area models down here, and we're going to first divide it into fifths. 1, 2, 3, 4 lines of 5/5. And then we're going to divide each of these areas into fourths to make up for this one right here, to account for this area model here. So we're counting for fifths with this area model and fourths for this. Yes, what about the whole number? Well, we're counting for the whole number by adding two whole numbers down here. We're breaking them up to figure out our answer. So we'll break this in each one into fourths. We cut it in half. And then each half into half. Again, cut it in half. And each half into half. Now what we create is two area models with 20ths. Now we have to account for all of the fractions in our area models on top. So we're going to grab our handy dandy highlighter here. We're going to make it red. So first we have a whole number right here. So we're going to fill in one whole number. This goes all the way to here. One whole number. And we're going to shade in this entire whole number to let you know that this entire whole number here is being used. So every square we fit in a little bit here. It doesn't be completely perfect, but I want to make it pretty good. Okay, so whole number. Now we have 1/4 here. So I'm going to go ahead and shade in this 1/4 here to accommodate this. Now, we're trying to figure out 3/5 of 1 1/4. Because remember, with a fraction, this multiplication means the same thing as of. 3/5 of 1 1/4. So we have 1 1/4 filled in now. Now we have to figure out what is 3/5 of 1 1/4. Well, take the highlighter here. Now we're going to go to blue. 3/5. Well, here we have 1/5, 2/5, 3/5, 4/5, 5/5. We already have it divided into fifths. We just need to figure out 3/5 of this. So here is 1/5 here, 2/5 here, 3/5 here. So now we just count those squares up. They're in 20ths. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20ths are shaded in. So 3/5 of 1 1/4 is 15/20ths, which can be reduced to 3/4. Let's check our math and make sure we're right. And do it the old paper and pencil whip method. We have 3/5 times 1 1/4. We have to convert 1 1/4 to a improper fraction. 4 times 1 equals 5 plus 1. Or sorry, 4 times 1 equals 4 plus 1 equals 5. So we're going to say 3/5 times 5/4 is going to equal 3 times 5 equals 15. 5 times 4, 20. 15/20ths reduced to 3/4. So we know we are correct. Very good. Moving on to number 2. Number 2, I want you to use an array. I want you to practice your skills of making an array. Remember, we talked about array is easy. All we're doing in an array is measuring and then adding. Measuring and then adding. I know with the multiplication question, saying adding is confusing, but when you do an array, you're just adding up the area. You're defining the area and then adding up the area. So let's move our 2 and 1/2 out of the way a little bit, just to make a little bit of room. On top, we're going to measure 2 1/2 across, and then we're going to go down 4. Let's measure. Each square represents a whole number, so this whole square is a whole number. We have to go across 2 and 1/2. So 1, 2. Well, this one we're going to have to break into a half so that we can count and measure 1/2. So we're going to draw a line here, breaking this in half and 1/2. Now we have to come down 4 whole numbers. 1 whole number, 2 whole numbers, 3 whole numbers, 4 whole numbers. Now let's outline our area. So here to 4, 2 1/2, down to 4, back across. So we've measured our area. Now we count. I'm going to label each block so I know to count. These are all whole numbers, so they are going to count as 1. This block is 1/2 of a total whole number, so I'm going to write the fraction 1/2 here. This is 1/2, this is 1/2, this is 1/2. So now I'm going to add it all up. First I'm going to add my whole numbers. My whole numbers are going to equal 1, 2, 3, 4, 5, 6, 7, 8. Adding them up, 8. Now I'm going to add up my fractions. Fractions, 1/2, 2/2, 3/2, 4/2. Well, that's an improper fraction. Convert that to a whole or mixed number. 2 goes into 4 2 times. So I got a whole number. I add my 2 numbers up. 8 plus 2 equals 10. So your area there is 10. You can check it. 2 1/2 times 4. 2 times 2 is 4 plus 1. So we have 5 halves times 4 over 1. We get 20 over 2. 2 goes in 20. 10 times. There's our answer. 10. And there was Mr. Klein. Okay, moving on. Now for the next, or for number 3, create a story problem to match number 2. Parents, if you want to help out, read your story problems with your students. Make sure they fit. It's a multiplication problem, so it should have some aspect of multiplication to it. For numbers 4 through 5, you can solve using any method you want. Multiplication, you can use an area model and array. You can use decomposing or improper fraction. For number 4, I'm going to use decomposing and Mr. Klein again. Or not. For number 4, I'm going to use decomposing, and for number 5, I'm going to use improper fraction. So, using decomposing. Decomposing means I'm breaking my problem up into 2 problems, my mixed number. So, I'm going to break my mixed number right here and create 2 multiplication problems. 4 times 1 equals, and then so first I'm going to do 4 times 1, and then I'm going to do 4 times 1/5. So 4 times 1 equals 4. 4 times 1/5 equals 4/5. Now I add these 2 products up, and I get the answer 4 and 4/5. That's how you do decomposing. You break the problem into 2 problems, you do the 2 multiplication problems, add up the products, and there's your answer. For number 5, I'm going to do improper fractions. So I'm going to take both my mixed numbers, I'm going to turn them into improper fractions. To turn to an improper fraction, remember you take the denominator, just color here, 2 times 3 plus 1. So 2 times 3 is 6, plus 1 is 7. 7, we keep the denominator the same. 7/2 times, same thing, 6 times 3 is 18, plus 2 is 20. 26. 7 times 20, 20 times 5 is 100, 2 more is 140. 140 over 12. Now we have to figure out how many, everybody turn this back into a mixed number. 12 goes into 140, how many times? Well, 12 times 10 is 120. 12 times 11 is 132. So 11 times, with a remainder of 8, 12. So that can be reduced to 11 and 2/3, which is our answer. The problem with improper fractions is sometimes you got to just deal with the big numbers and figure out, okay, how many times does 12 go into 140? So 12 goes into 0 times, and 14 0 times, and goes into the 11 times. So 11 times 12 equals 132 minus equals remainder of 8. There you go. Numbers 6 through 10 are all story problems involving multiplication. Again, you can use any method you want. You can use mixed number, or so you can use decomposing, you can use improper fractions, or an area model array. So for number 6, I'm just going to use improper fractions. Easy problem to do. I have to multiply 25 times 1/5. Hillsborough is 25 miles away. Julie has driven 1/5 of the distance. How many miles? 25 times 1/5. Remember, 25 is a fraction. Can be 25 over 1. 25 times 1 is 25. 1 times 5 is 5. 5 goes into 25 5 times. Our answer is 5. So she drove 5 miles. Now, number 3, I'm going to do an array to show you how to do an array again. Give me another example of doing an array. So I'm going to make my array. So 2.5 by 3.5. I have to, remember, I have to measure, adjust the size here a little bit. So I'm going to go, so you can delete that and draw another one. I go 2.5 by 3.5, so I want to make it longer. A longer rectangle here. Remember, for an array, I measure and then add. So I'm going to go across 2 1/3 and down 3 2/5. So make my array, I have to break it up into 2 1/4 going this way. So I'm going to break this into thirds to account for my 2 whole numbers and be able to account for my fraction in addition. I'm going to break this into thirds. Let's start measuring. 1 whole number, 2 whole numbers. Now I have to break this last whole number into thirds to be able to measure the third here. That's really awesome. We do that here. Marker would draw a straight line and be awesome. Then count 1/3. So I'm going to stop right here measuring across the top. Now I'm going to go down 3 2/5. Well, I have to have 4 whole numbers coming down to account for my 3 whole numbers and my fraction. So I'm going to break this into fourths. I'm going to cut it in half first, and then each half into half. And I have 4 whole numbers, so I can start counting. 1 down, 2 down, 3 down. Well, now I have to break this last section into fifths. Okay, so, and 2/5. So here's 1/5, then 2/5. So I stop here. Now I figure out my area. So it goes from here down to here. And tomorrow on the test, you are perfectly allowed to use a highlighter on the test to highlight the area of your array if it makes it easier for you. Now I go back to my hand pen here and I count up. Well, I have 1 whole number here, another one here, another one here, another one here, and another one here. Over here, this is 1/3 of a whole number. So 1/3, 2/3, 3/3. Across the bottom, I have 2/5 in these two columns. So 2/5 here, 2/5 here, and then this whole number I had to break up into 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But I've only highlighted 2 of these 15s as part of my area. So here I have 2 15. Let's add everything up. Well, first I'm going to add my whole numbers. I have 1, 2, 3, 4, 5, 6 whole numbers. This is why I like doing arrays. Arrays give me an opportunity to take some shortcuts. On my fractions, if I pay close attention to adding my fractions, I have 1/3, 2/3, and 3/3. Well, 3/3 is a whole. So I'm going to add another whole number. And I'm going to cross out these 3 fractions because I already accounted for them. 1, 2, 3/3 equals a whole. I don't have to add those fractions. Make it easier on me. So then I have 4/5, 2/5 here, 2/5 here, plus 2/15 here. In order to add, I have to convert to an equivalent denominator. I already know that 5 goes into 15, so I don't have to change one of them. I only have to change the fifth. To get 15, I have to multiply times 3. So I multiply the numerator times 3, so my new problem is 12 15 plus 2 15, which equals 14 15. So my fractions are 14 15. My whole numbers up here, remember I counted for these fractions on the side, so I added to my whole numbers is 7. So 7 plus 14 15 equals 7, and 14 15. And that is my answer. 7 and 14 15. I like doing arrays because it gives me the opportunity to visually see the fractions I'm adding up and figuring out the equation. With improper fractions, sometimes the numbers can get really high. With decomposing, sometimes it can get really complicated because you're adding and multiplying different things. I just like arrays because I like being able to look at it. Makes it easier for me. Number 8, I'm going to do by improper fractions. I have 2 1/2. There are 2 1/2 truckloads of pigs in the parking lot. The pigs are getting ready to go to the farm. 3/5 of the pigs on each truck are males. How many trucks would it take to carry only the males? So I have to multiply 2 1/2 times 3/5. Find an improper fraction. 2 times 4 plus 1, or 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. Half times 3/5, which goes straight across. 5 times 3 is 15. 2 times 5 is 10. 10 goes into 15 once, with a remainder of 5. 5 is half of 10. I can reduce this to 1 1/2, which is my answer. Number 9, I'm going to do by decomposing. So I have 4 1/2 times 1 2/7. Remember, decomposing is when I take one of my mixed numbers and I break it up. I'm going to take 1 2/7 and break it up. So now I have to multiply 4 1/2 times 1, and then 4 1/2 times 2/7. So 4 1/2 times 1 first, and then add them up. 4 1/2 times 1 equals 4 1/2. That one was easy. My next problem, 4 1/2 times 2/7. Okay, 4 1/2. 4 times 2 is 8, plus 1 is 9, so I'm going to have 9 halves times 2 sevenths can equal 18 14th. And convert that back to a mixed number. It's going to be 1 and 4 14th. And I have to add these two up. So 4 and 1/2 plus 1 and 4 14th. 2 goes into 14 7 times. And we'll put times 7 times 7. My new problem is going to be 4 and 7 14th. Let me write 7 14th plus 1 and 4 14th. So 5 and 11 14th. That is my answer. Can't be reduced. Moving on. Number 10, I'm just going to go ahead and do the improper fraction method. Figure this out. Picnic tables at Bond Park are 3.5 feet wide by 5.25 feet long. Mr. McBurnett will bring a tablecloth with an area of 20 square feet when he has a picnic at Bond Park this weekend. Will this tablecloth be large enough to cover the picnic table? Why or why not? So, our first thing we have to do is we have to multiply 3.5 times 5.25. So 3.5 times 5.25. Let's do improper fractions. 2 times 3 equals 6, plus 1 is 7. Bring the denominator down. 4 times 5 is 20, plus 1 is 21. Bring the denominator down. 7 times 21. Like I said, improper fractions, the numbers can get pretty big. 7 times 10 is 70. 70 times 2 is 140. Times 1, 147 over 8. Now we have to figure out how many times does 8 go into 147. So 8 goes into 1, 0 times. 8 goes into 14, 1 time. 1 times 8 equals 8. Okay. 7. 8 goes into 66. Drop the 7 down. 8 goes into 67. My connect's drawing a blank. 8 times 8 is 64. There we go. 8 times 8 times 8 is 64. Remainder of 3. So 18 and 3/8 is our answer. There you go. That's the review. Go back and look over any problems you might have had problems with. Pause, rewind, use the video up. Test will be in the exact same format. The stories and the numbers might be a little different, but if you can finish this tonight, you'll be in great shape tomorrow. Good luck.